Good morning, everybody. We are about to start, and today our first speaker is gonna be Andreas Petzold. Is the coordinator of ENVRI and also has been involved in the European Research Infrastructure EAGOS and is also leading the Global Observations Department at IEK8. So, Andreas, if you're listening to me, you can just go ahead, share your screen, you name it, the floor is yours.
Thank you very much. Can you hear me?
That's pretty much all.
Good morning. Can you hear me? Does it work?
Yes, we can hear you.
Thank you so much. So I will share my screen and welcome you. So
we have around 10 minutes for each presentation.
Yes, I understood. Thank you so much. So good morning, everybody, and my apologies that I can't be in Grenoble in person. It's a nice place, but times are busy. But I'm happy to introduce briefly the cluster of environmental research infrastructures to you, which is the counterpart to PaNOSC in the environmental domain of the S3 research infrastructures. So as I was introduced, my name is Andreas Petzold. I'm working at the Research Center Jülich in Germany, and I'm heading here one research infrastructure together with a French colleague that's called EAGOS, and we are running the ENVRI cluster as a whole together with my colleague Anka Hinola. She is in the program. She should be here, but unfortunately, she is on sick leave. So again, apologies. So I stepped in here. Good. So to give you a brief background of who we are. So you are used to infrastructures working in the photon and neutron sources environment on material science, imaging, etc. And we are working in a completely different field, and this is the environmental sector. So our cluster combines research infrastructures which are active in atmospheric research, in ocean, open water and inland water research, land research, and terrestrial ecosystems. So we cover everything which is relevant in Earth system science. And with this illustration here, you see that we really have a broad coverage of methods and of also cultural approaches to research, and to show you a few of the key features which determine a bit of the way we approach the science cluster projects. I give you some highlights of the key features of environmental infrastructures, which are, as I said already, completely different to your field. So we run highly specialized observation and analysis platforms for these four subdomains, like aircraft, ships, underwater platforms, drifting buoys, land observation platforms of all kinds. This is all included in our field. Our observations are often unique. You can't repeat that. That's different to your field. We cannot start a similar experiment in the Earth system science. We have to cover a wide range of disciplines for all these, to cover all the four subdomains. And in consequence, we have multiple infrastructures which are part of our cluster. And these infrastructures show a high level of specialization because each RI needs to concentrate on their main tasks and specific user communities. However, our data have a high importance for society, economy, and resilience of the society, because we document climate change in all facets. And to answer that, to respond to societal challenges, we really need to develop multidisciplinary methods. And here, the resources from the cluster project help a lot. And in total, we can simply summarize that answering societal needs is only possible via collaboration. And this is a core statement of our cluster. So we are the providers of data and research products from the 4 subdomains of the Earth systems, and our data are crucial European contributions to the monitoring of the state of the Earth. All infrastructures are operational, and we are embedded in international frameworks. So our data are vital for assessing past and defining future policies, not only for science, but also for decision making. And the project here, the ENVRI project, helped us to build up a portal where we can provide research data and services at the European Open Science Cloud through the ENVRI Hub. So this is a brief statement of what we did and still do. The landscape in approximate numbers is shown here. You see we are highly diverse. So our community is built up of 13 research infrastructure, 1 data infrastructure, and we have a lot of operational research infrastructures with many data portals. That's where we came from. And if you look at the number of researchers, you see that they count up to high numbers. And we, as said, we cover a high diversity. And just to give you an example of the spread of infrastructures we have in our team, look first at the top left, the Argos research infrastructure. That is my home ground. So we perform the monitoring of atmospheric chemical composition by instruments flying on routine passenger aircraft. Our data are mainly time series of key essential climate variables, quite simple. On the other hand, DISCO, for instance, is the distributed system of scientific collections. Their targets are species or a specimen sampled in museums, for instance. And you see here the broadness of the infrastructures we cover in our cluster. And ICOS, as another extreme example, they deal with the integrated carbon observation system, the global carbon cycle. And they need to concentrate not only on one subdomain, but on atmosphere, oceans research, and on the terrestrial ecosystem science. So they have to work cross-domain. And these extreme examples show you the spread of the infrastructures we have in our cluster. So behind that, the operational infrastructures, the community is even broader because we have many RIs which are under development. They are still in the course of being built up, or like Elixir and ENVRI, they work in the environment domain and, for instance, in the life sciences domain like Elixir. So we also work cross-domain already. And we started about 10 years ago with the first cluster project, with the building up of the community. And then we had another successor project to expand our capacities by developing joint technologies, joint approaches for handling data, etc. And now we are in the third project, and we are building up operational services. And as the title of the session is, what do we get from all of that? So here we could implement fair data management systems at our research infrastructures. We developed the landscape of the environmental RIs. We were able to align our data management systems from these very diverse background, from these very diverse infrastructures. And finally, we managed to build up first examples of interoperability within the environmental domain. And the next step is to go across the domains, for instance, to collaborate with PaNOSC RIs. And as a result, which is then exposed to the outside world, we were able to build up the ENVRI Hub, which is the portal, the collaboration platform for the environmental research infrastructures. And this is here, it helps us to increase the fairness of our data by implementing a lot of these fair enabling resources, and to work on the disciplinarity by science projects, which you can visit there. And we were able to also perform joint technology development. That all was possible by the support of the science cluster projects. And our target groups we are reaching out now is originally the scientific communities, of course. Our domain scientists, they simply access still the services by their traditional routes through the portals or the APIs. But we also reach out for research infrastructures as a whole to share knowledge, like implemented technologies via our knowledge base, for instance, or training resources. That has all been developed in the ENVRI Hub course. And we will expose more of our services to the users of the European Open Science Cloud to go through the ENVRI hub to our resources guided by rich metadata. That is the final project we get out of that. And that is a big success in aligning this highly diverse cluster and building up first interoperable services. And we are not at the end. We started really from a very diverse landscape through a winding road. We are now reaching for the level of fair services for the ENVRI cluster, but we can even go further. But without the science cluster projects, we would have not been able to even start that journey. So this was for us a Kickstarter to bring this diverse community together and develop first interoperable approaches. Big success for us, and I think the European Open Science Cloud is acknowledging this kind of developments in all of the science clusters, which you will see in the presentations after mine. And with that, I want to stop. Thank you.
Thank you very much, Andreas. So I'm wondering, do you have any questions online for Andreas, maybe? No questions online. And the people here in Grenoble, is there anyone that has any questions? Don't be shy, please. We are starting strong today. Okay, well, we will give time to reflect to the audience here and online, and then we'll move with the second speaker today. And that would be Giovanni Lamanna, is ESCAPE coordinator and is also director of research at the CNRS and the LAPP director.
Good morning.
Good morning. We can hear you, and you should be able to share the screen.
As you see, I'm using the background screen from PaNOSC, but I'm not from PaNOSC. I'm sharing now. And now tell me if it is okay. Do you see the slides?
Yes, we see the slides perfectly. Thank you.
Okay. ESCAPE is the European Science Cluster of Astronomy and Particle Physics free research infrastructures. The S3 world-class projects that are involved in the ESCAPE cluster are presented through their own logos. We have the landmark high luminosity LHC at CERN, as well as a FAIR at GSI, two infrastructures in particle and nuclear physics accelerator-based projects. Then we have a series of projects that are in the domain of astrophysics, astronomy, astroparticle physics, CTA Observatory for the gamma ray astronomy, Virgo for the gravitational waves, ESO with a focus on DLT, as well as other infrastructures, the European Solar Telescope, JIVI-ERIC, that is the consortium of radio telescopes, CountryNet for the detection of cosmic neutrinos, the LSST Vera Rubin Observatory for cosmological survey, and SKAO, that is the organization of the next generation radio observatories. As per for the other classes, those S3s or other world-class projects brought together a series of national institutes. We have 2-3 institutes per each project that were focused their participation in ESCAPE on some specific activities, but more or less all the projects were all the S3s were interested and were partners in all the work packages in the full work program of ESCAPE. That is going to end. We already had our conclusive events a few weeks ago, and it will over by 31st January next year. To present ESCAPE, I would say that it was built by based on common needs from these two communities that were not used to work together before, since both the astronomical observatory and the nuclear particle facilities operations require global open access to data, long-term curation, and sustainability. Furthermore, what they have in common is that together they are going to become a generator of exascale volume of data. We need to support the tradition, therefore, of the ESCAPE community of being early adopters, innovators in information computing technology for the data management, largely speaking. We have been leveraging two complementary excellences, the fair data stewardship in astronomy with the virtual observatory infrastructure, as well as the expertise of the high energy physics in large-scale data management and distributed computing. The main challenges that were ahead of us when we started the cluster were trying to apply sort of economy of scale, because at the end we had a series of common national agencies supporting all these ACE3 projects in the two disciplines. Therefore, we needed also to bridge sociological barriers, bringing scientists to work together, and furthermore supporting the cross-fertilization between technologists, scientists, data scientists, with the perspective of participating in the implementation of the European Open Science Cloud, but motivated by the need of bringing together data from different sources to combine through a multi-product approach the way to respond to fundamental questions in our scientific domains. We want to also to look forward to build a sort of inter-research infrastructure virtual environment for fair research and for open science, on top of the dominant implementation of analysis platform for each single RI. And therefore, we wanted also to combine, from one side, the continuous support to the implementation of this long-term, large, big science project in the ES3 roadmap, but also with the strategy of uptaking open science with interpreting, let's say, first of all, the EOSC concept. Because at the beginning, in 2018, EOSC was a concept. And the work program that ESCAPE established and for which we have been working in the last 4 years was really aimed to interpret EOSC for our domains. And this is the interpretation. We developed and delivered a scalable federated data infrastructure as the basis of open science for the ES3 projects within ESCAPE, that is the data lake. We work together in establishing common services for then customizing or even for transversal workflows of science platforms for the different ES3s. In the same time, from the beginning, we presented the software as an important part of data, an important part of the digital objects that are matter of openness or fairness. Therefore, we commit in building a first repository registry of scientific software for our domains, that is the OSSR. Finally, we consider the importance of connecting the existing fair infrastructure, such as the virtual observatory, to EOSC, and furthermore, on the other side, connect the virtual observatory with the new requirements of the next generation facilities. And therefore, we made development and we adopted also standards and methods applying the VO. Finally, we consider that EOSC wanted to open science or bringing citizens, fellow citizens, also in the scientific research process. Therefore, we supported also citizen science initiatives. Finally, we achieved in all of this, but we made even more. Since the beginning, you see, and I think it will be also reproduced by the other partners, the other clusters, we established really a strong cooperation and coordination among the 5 clusters, that at the end, the very end, in June 2021, became also a platform, a synergistic platform for a position statement concerning the future. And we are also working together in developing further services for open science, cross-ERI, but also cross-clusters. I will not go in detail, but I promised to Andy to show 2 of these subjects on which there is already a bridge between PaNOSC and ESCAPE, and I'm convinced that in the future we have to work out a potential cooperative scheme. One is about the data lake infrastructure, because born for the large volume of the data is now applicable to everything. And the concept of the virtual research environment, a sort of web-based environment where we have a sort of composition of services where the scientists are uploaded, or they uptake open science for the complete workflow of their scientific analysis, but having all the availability from software to data to services. And this is also concerns the OSSR, the Open Science Catalog, with all the services, which allows for a quality of service repository in continuous development. I want to conclude my presentation by responding to the question that was addressed by the PaNOSC management for this occasion: what the H2020 ESCAPE project has changed for the related community. First of all, I repeat 3 out of the 5 major challenges, because they were really met and overcome. But then we have products like the deployment of the long-term community-based services for free science, the EOSC scientific content accelerating the support for open science project with EOSC Future was a major product. And then we have some byproducts that I believe are extremely important today to mention. The intercluster coordination, as I said before, and the base for an even larger multi-domain cooperation, bringing some content to EOSC, but also develop a sort of openness of science in terms of multidisciplinarity. New ESCAPE collaboration agreement is an important byproduct, because we concluded with the H2020 with a new collaboration agreement signed to open up an avenue for the future of the ESCAPE actions for all partners, and extend it even to more than the current RIs that are encompassed within ESCAPE. This implies also a support and the synergy with the current open science project within EOSC Future, with the joint ECFAP, ECNUPEC activities. Those are the consortia of national institutes in Europe for accelerator physics, for astroparticle and nuclear physics, respectively. We are experiencing also a fruitful participation in the European Commission stakeholder surveys as a cluster, and together with the other 4 clusters, speaking as much as possible with one voice in support at the end, not only to the EOSC implementation, but also to support excellent science. A longer-term role, including on complementary focus, in the sense that, as I said before, the fairness is the key goal of our action, but the quality and the success of the cluster approach opens up possible new focus. And why not the fairness of data, also the fairness about the technology data, the more implication of whatever is our domain in management of the project, in society, in socioeconomic impact, and so on and so forth. Of course, we are stronger to consider to make a step forward to support the idea of economy of scale that is required by our national agencies, by organizing some key competence concentrated and seconded by different RIs, something still to be explored, but is under study. And then I would say that altogether, if I look back to 2018 and 2019 when we started, when as I said, yes, as I said, it was just a concept, EOSC. Today, we put in place services and participation to even tackle any new emergency that we could have to face with a sort of data-intensive virtual research environment with the services data that could help to minimize the impact of such an emergency in society. Thank you for your attention.
Thank you very much. And do we have any question in the room for Giovanni? Anyone? Yes, we do. That's very good. That cheers me up when people participate. It's early in the morning, but let's go for it.
So thanks for the presentation. I have a question to both Andreas, Giovanni, and Andy. I see the convergence of the goals and the approaches. I was curious about how much of the effective implementation is shared and how much we are duplicating the effort. So in which sense we could also, let's say, put together the resources in and things could be shared among these three clusters.
Which resources you have in mind in your question?
Well, for example, you have shown the concept of the portal in order to access the data lake, so on and so forth. So this implies some development in the technology on the higher level. And then there is also a low-level implementation that bridges the single research infrastructure. So the low-level one would be particular to each cluster, but I can imagine that the higher level portal and data access could be following the same kind of technology, or at least shared and having a common access place.
So if I'm allowed, I would reply, then I will give the floor to Andreas and Andy. I believe that we have to keep in mind the agendas, human agendas. So we had the steps, we had goals to achieve, progress to make, services to develop and deploy for already our large communities within a cluster. Today, the discussions and the plans for cooperating in developing service in common or share solution are really one of our highest priorities for the next months, the next years. And we will do this because indeed is exactly what you are wondering about, is that exactly as we did research infrastructure, inter-ARIs within a cluster, even inter-clusters, so we have to try to apply an economy of scale, because behind the economy of scale approach is a question of the working together and a cross-fertilization between domains. If we are able, indeed, I made a couple of examples, the data lake services or the VRE, if we are able to support a series of services that are based on the scientific requirements, we are already implementing and involving the scientists to a continuous development with a sort of foundation approach of those services for their goals, instead of developing something in IT and running after the users. This is a completely different approach, and we look forward to succeed in this.
If I may, just to add on, so many things have already been said by Giovanni. The way we do that with this, the use of these, and you are correctly entirely right, to these kind of high-level services, more generic services, which are applicable to all research infrastructures, independent of their specific needs and requirements. We develop amongst the clusters an approach, and that may happen in upcoming European cluster projects, to drive that process by kind of use cases. So as Giovanni said, we need to have concrete examples for collaboration, and we use that also to develop the underlying technology. And from that we will see which kind of techniques are we, for instance, in the environmental domain can adapt from the ESCAPE or the PaNOSC consortium. There are for sure some methods we can apply, some does not fit because our data structure is completely different. This will be driven by use cases or science projects, we call it. And I think that's a proper way to go forward, to work from the content and from the targets and develop the underlying technology. And then at the end, you have a product to show to the outside world. But we are aware of that, and this is on our agenda for the coming month and years, probably. Thank you.
If I could just add one comment, I fully agree with Giovanni and Andreas, but we did start already during the summer an analysis, a matrix of all the different, the 5 clusters and all the solutions in the different areas. And now the idea is to converge on these. One thing that is, I think, missing in this new call, it's a very modest budget for what we call consolidation, so this kind of work. And I think if we want to go further, we would probably need additional budget. Yeah.
Okay, we are a little bit behind a schedule, so we will go with the next speaker. And Patrick is really insisting. Are you going to be super brief, I hope?
Good morning, this is Patrick from DAISY. I just want to follow up on what Andy said. So on your consolidation in the 0101 in preparation of the call of the proposal, will you give preference on cascading calls which will include at least 2 clusters? Is that planned? Because then it would be more serious what you just said. So if there would be something at least
Patrick, first of all, thanks for the question and nice to hear you. Patrick, I believe that we have to keep in mind 2 things. The first of all is that although we have a limited budget for consolidation, we should use this budget. Therefore, if we have to, for instance, something that you know very well, if we have to consider to reinforce and to strengthen the cooperation already between PaNOSC and ESCAPE, and thanks to you and DAISY as well, around the data lake and the VRE, we should bring this ahead in the consolidation. Then, concerning the cascading grant call, this is a call addressed to all open science projects and services. Therefore, in my opinion, is the quality of the project that will be presented by consortia, but also by single researcher, that can also take a service on top of the existing one, but should be something new. And in case, because of the limited budget in consolidation, as you said, there is something that needed to be supported because it's new and represent the convergence of more than a couple of clusters, yes, you are right. It could be that we should envisage to make something transdisciplinary, trans-clusters. But there are not, let's say, rules for that, because the call has to be open as much as possible. It's up to us as a community, not the cluster, community largely, whatever is the community, to be informed and to be prepared to propose something really useful to this call.
Okay, thank you very much. And now we'll go with Franciska de Jong, that she has been very central to SSHOC and is the executive director of Clarin. Franciska, if you are ready, you can share your screen, and you're in mute, by the way.
Yeah, and I'm also invisible.
No, now we can hear you. We can
the slides are there, right? Okay, very good. Let me clean up my own screen a little bit. Okay. So this is my opening slide. Yes, indeed. My name is Franciska de Jong. I'm the director of Clarin, ERIC, the research infrastructure for language resources, which is participating in the so-called SSH Open Cluster, which is the collaboration in the domain of social sciences and humanities, as a follow-up of the cluster project SSHOC, which ended in April of this year. I'm very pleased to be able to introduce you to some of the things that we were able to work on in the SSHOC project, which was quite successful in bringing together parties that until a few years ago knew of each other's initiatives, but were not well aligned, and we also a lot of potential for doing things together, and that indeed, with the budget of the European Commission, led to a number of quite interesting results. In this presentation, I will give a few general background. I will address a few general background issues, and then I will focus on two main results. One is the contribution to the certification of repositories and support for nodes in the network that would like to go that way, and the common platform, discovery platform, that is called the SSH Open Marketplace. So you see now a slide with the facts and figures for the SSHOC project, not very interesting in itself, but the objectives below, even though they are very much in the line of the typical project with rhetoric, I think it's good to mention that here the goal was indeed to make sure that the social sciences and humanities were well connected to the European Open Science Cloud as an ecosystem, and that there was maximized reuse of data and other resources through the principles of open science and fair. It was also meant to make sure that new infrastructures, upcoming infrastructures, could also be incorporated in the process, and of course there was attention for a proper governance model. So in this slide, you see the on the left-hand side, the 5 ERICs that were the main beneficiaries of this project. CESDA from the social sciences, Clarion, of course, DARIA for arts and humanities, the European Social Survey, and SHARE, which is a research infrastructure surveying phenomena or communities to study phenomena of aging and retirement. On the right-hand side, you see the initiatives that were invited to join. Some participated already in the project, others joined later on. I will get back to that in a minute. This is an overview slide demonstrating that indeed, as expected, we produced a number of key exploitable results in line with the objectives that I just presented, and a service catalog. But in this presentation, I would like to go into a bit more detail of the way we approach the center certification. But in order to do that, I need to tell you a little bit about the SSH-specific challenges and opportunities taken up in the project, and now in the follow-up initiative SSH Open Cluster. So as we all have this goal as research infrastructure, we need to demonstrate our relevance for the support of the implementation of public policies. So we did some work in response to COVID-19. We created lots of data sets, or corpora, we call them, specifically annotated for COVID-related pieces of information. The cluster has a wide coverage of UN Sustainable Development Goals addressed, and we have a number of science projects in the project EOSC Future, and these are typically the ones that try to build links between the domains. So, for example, between SSH and the health domain, or between SSH and the environmental domain. Interoperability is a key instrument to capture social and cultural dynamics in the wealth of data that is around us. But there's a few very specific features of these resources, and that's the diversity. Also, not only of the data types, but also of the workflows and the scholarly cultures. For example, there is a lot to cover or to address multilinguality, multimodality, diversity in terminology, etc. And of course, there's also multidisciplinarity within the cluster that requires specific attention. And maybe another specific feature is the fact that lots of data collected in the context of this cluster have longitudinal value. So that also requires specific measures. Okay, so in the repository landscape for the SSH domain, there are a few characteristics to be mentioned, maybe very much overlapping with what is the case in the other clusters. So there is distributed service provision, there is room for depositing new services, there are discovery platforms based on harvested metadata, all in all underpinned by a mature model of service federation and fairness of resources. So interoperability, as I already said, very important, identity federation. But given the dominance of textual resources in most of the research infrastructures, there's also attention for federated content search, where you can directly search into the texts made available. There are a lot of nodes that may be a specific feature of the SSH landscape. We all have a distributed nature, and even within the countries, there are often multiple nodes connected to research infrastructure. So all in all, there are over 400. But and not all of them are data repositories, but in the entire landscape, there are at least 50 Core Trust Seal certified repositories. To go a bit into the detail of these certified repositories, I now focus a little bit on Clarin because that's the angle I know best. So center certification in the context of Clarin is arranged through the work of an assessment committee. Currently, out of the almost 200 nodes, there are 25 certified centers, Core Trust Seal certified, but they also comply with some Clarin specific requirements related to the specific nature of the data, and language tools. And there are many more centers with partial compliance for Core Trust Seal. The metadata standard is CMDI, component metadata infrastructure, plus a range of conversion workflows. So if other metadata have been followed previously, conversion is well supported. The catalog of harvested metadata is the Virtual Language Observatory. And there's a lot of support in terms of best practice guidances, tutorials, etc. And the principles are maybe also good to mention, and it is that we aim at compatibility at protocol and format level, but we also acknowledge the unique situation of each center because of the prehistory, the organization, the technology used, etc. So the focus is on the strengths that a center can contribute to the wider landscape. There is an offer of reuse of existing solutions, but there's no obligation to use specific software stacks, and the combination of do-it-yourself and reuse of existing solutions is encouraged. Now back to SSHOC. In SSHOC, there was a specific work package aimed at trust and quality assurance. And the strongest centers with a lot of CTS certified nodes, they're listed here. A model for support was set up to upscale the less advanced nodes in the overall SSH community. So we offered a training program for 14 selected repositories. 8 of them really aimed for Core Trust Seal certification. The others were mainly interested in learning how to arrange self-assessment without the immediate intention to apply for Core Trust Seal. And we learned a lot of things about the challenges and the aspects of the support that they found useful, which is important because we want to continue that model also in this 0101 consolidation project that was discussed a few minutes ago. Sustainable management of trust, we learned, goes well beyond certification. So everyday interaction in the network between the users and the stakeholders is very much needed. And a keen eye for diversity in the organization is also very important. This is a slide with some documentation that you can check later on. I also want to say a few things about the SSH Open Marketplace, the common discovery portal for SSH resources that was built during the SSHOC project period. It is not just aiming at data, but also on training materials, on workflows, and publications on top of tools and data. And there are 3 guiding principles, namely, the discovery should support the need to provide to have also information available on the context of a resource, on the way it was curated, and on various community specific aspects such as publication channels, connections between publications and tool descriptions, etc. And of course, this marketplace is an entry point to EOSC. It is one of the services registered in the EOSC portal.
1 minute, please,
Yeah, I'm reaching the end very soon. So here you see which of the initial trusted sources played a role in populating the marketplace. We extracted tool descriptions from publications. Curation tasks were, support tools for curation tasks were built. And here you see some numbers for what was integrated at the end of the project. Meanwhile, these figures have gone up. A maintenance and governance model for the future of the marketplace was defined in an agreement between CESTA, Clarin, and Daria. Initial duration of the agreement is 1.5 years, but we definitely hope to find ways to continue that. It's a combination of, the agreement comes with a contribution in kind and cash, and there is a creation team, including volunteers from the community. So this is my last slide, and I showed it already before. One of the aims of this a new model of collaboration is to also formalize the relationship with the new and upcoming open science research infrastructures on the right-hand side. And very soon we will open a discussion on the model that we call rules of participation. Thank you.
Thank you very much, Franciska. And I propose, we are running a little bit behind schedule, that we go with the next speaker, and then we'll have time for questions in general for the panel. And
I'm happy to take questions in the chat in the meantime.
Okay, that's good to know. And the next speaker is Niklas Blomberg, EOSC Live Coordinator and Director at Elixir Europe.
Thank you very much. I hope you can see the screen.
We can, and we can hear you, so all is good.
Excellent. So thank you very much for the kind invitation, and it's a pleasure to join you. I'm sorry I couldn't be in Grenoble. It's a really nice place. But so I would like to share, as the instructions, just a few thoughts on what EOSC Life project changed for the life science community. I guess what is it that we took away from our cluster project, and hopefully that's also a good starting point for conversations on how we can work together in the future. So EOSC Life, when we started the project, we said we wanted to create an open collaborative space for digital biology in Europe. So the background to this is, of course, that biology, like all other disciplines, is getting more data rich, and we have larger and larger data sets coming out from new sort of high throughput ways of assessing life. And the cluster is quite diverse. We are spanning everything from molecular structure measurements, some of which are taken at synchrotrons, like the one in ESRF, up to long population biobanks, sort of national biobank cohort studies or clinical trials following groups of humans over years. So it's a very large sort of diversity both of time scales and of spatial scales in the measurements. And so when we wrote the project, what we set out to do four things, really. So the first, we said we will establish an EOSC for the life sciences and do this by publishing fair life science data resources into the EOSC. And we've done this using a registry, existing registry, fair sharing. I'll come back to that. We also, because many of our data sets are sensitive, we wanted to provide policies, guidelines, processes for secure and ethical data reuse. And we have what we call the sensitive data toolbox that is being used to guide some of this access. But it's not enough to have data sets and data access. Of course, in the life sciences, like in many other disciplines, a lot of the science these days happen by people who invent new software or analysis methods. And we really wanted to find a way of helping this community to use their tools in EOSC. And so we have had a large activity on what we call populate an ecosystem of innovative tools. But it's really about software and workflow packaging and being able to deploy that effectively within different types of workflow managers, but also to register this software so that it can be sort of openly accessed and reused by other people in the community. And if we've done all of these things, that should be useful for scientists. And so we had a large activity in the project with open calls, where we opened up for the life science community to work with us in the project and sort of provide use cases or problems, and we would work with them in an open call or in projects following open calls and try to use the kit that we had built in EOSC Life. And we wanted to do this and align that with the major sort of societal challenges, and we've seen this from the other presenters as well. It's about how do we adapt to climate change, about healthy oceans. So we have ENVRI is our marine biology research infrastructure, soil health and food. And so we have, of course, a lot of agriculture and plant phenotyping centers in the cluster, and then health and cancer. But the project had not more than started, actually, before a big use case sort of barged into the middle with the pandemic and COVID-19. And a large part of our cluster project was actually refocused towards the response in COVID-19. And we had a top-up and extension of the project to support some of the sort of easy pandemic response activities. Now, I'll come back to that, but that really drove a lot of the agenda for us over the last couple of years. What has come out of this, and I think I wanted to just highlight that, I think that's really quite interesting. So we have, following the pandemic, we have 2 pairs of projects that is now keeping the community very busy. The first is towards COVID-19, the green one, and it's a data project called By COVID, which is really about consolidating data from infrastructures and other actors and bringing that towards the COVID-19 data portal. And it's paired up with a transnational access and ENVRI project called Isidore, which is then providing open calls, transnational access calls to research infrastructure from the community. And we just have started a very similar pairs of projects where there was a call in the EOSC part of the work program for data consolidation towards the cancer mission. And the project there is called EOSC for Cancer. And a paired up call, also again an ENVRI call for infrastructure access towards the cancer mission called CanServe. And in both cases, these 2 projects are working together so that we are essentially reusing the EOSC Life developments and pipelines to scale up data management processes and data analysis opportunities for the users at the infrastructure facilities, and then making sure that we harvest that open data and publish that in an open science way in various portals. And I think that this has been really interesting. It's far from easy. It's by COVID, Isidore is the one that has gone furthest for about a year. It's really quite complicated to scale this up. But I think this is a really interesting opportunity. And I hope we'll see more of these sort of paired approaches in various communities, because I think it's a very effective way of supporting research data management from research infrastructure facilities. Now, I'll come back to what I think is coming out here. So coming back then to what did the science cluster change for us? Well, following on from what I just said,
2 minutes left, Niklas, please.
Yep, perfect. Is that it provided a collection of cross-RI reusable services for data management and analysis. And we see here a whole collection of logos in the little box. And I think that points to one of our approaches, which is that we didn't invent a great deal of things from new, but really we built on things that already existed. And I think that's made sustainability a lot easier. So we have had already existing registries like fair sharing for our metadata standards for databases and policies. We have standards like RO Crate for packaging, and we have toolboxes like Galaxy for analysis. And we simply built on those. And they are now being picked up by a whole set of new EC projects and carried forward. And I think that that's helped us with sustainability. And maybe in the interest of time, I'll skip this, but this is one example of how this sort of toolbox have been applied in by COVID then to mobilize data from a whole range of different facilities and organizations, connect and standardize that data, and then sort of expose that to the community via Galaxy and other platforms. So the second thing that I think the clusters change for us is really our experience of running cross-research infrastructure user project, and that really came out of the open calls. And so I think we've built up experience and a set of trained a set of project managers who are very used to working across the research infrastructure facilities. And I think we are reaping the benefit of that and really seeing how this is helping now the alignment within the transnational access projects and the coupling of the transnational access with data publishing. And then if we look at the third thing that I think the science cluster changed for us, it is really the cross-cluster collaboration and the adoption of services across clusters. And I put 3 examples here really quickly. One is the training portal, which we've seen uptake in several other places, including the EDI, the data stewardship wizard, and we saw that mentioned also in Andreas' talk, but it's been used now across several of the research infrastructures in other domains. And then I think the collaboration between the science clusters have been beyond excellent, and I think we should give credit to Giovanni, who's on the panel, for really driving that alignment and the collaboration between the clusters. I think that's been a really rewarding experience of the cluster projects. So with that, I'll stop and happy to take any questions.
Thank you very much, Niklas. And we are running around 50 minutes behind schedule, so I'm wondering, is there anyone that has any question for Niklas or for the rest of the people in the panel that have participated today? Anyone? Ah, yes, I haven't seen her. Okay, here I come.
Thanks. Interoperability was mentioned a few times, and I was wondering if you could comment a bit on the specifics of achieving interoperability. Is this focused on semantics, or is it focused on, I don't know, converters?
So
I can say a few things.
No, no. Yeah.
Yeah. Well, as you already indicate, interoperability is a notion with many layers. In building the infrastructure, you need them all, but in technical sense, interoperability, as also meant by the I in the concept of FAIR, is about the possibility to find and reuse resources. And a very important criterion then is, of course, of instrument is to work towards interoperability of metadata. But there are other layers that could enhance that concept. Niklas, you are waving your head.
No, I thought I could build on that. So I think.
Yeah, please do.
So we have, for us, we have focused on interoperability in several places. So one is around the tools and the software, and I think that's probably what you would call technical interoperability, but really the ability for help tool providers to deploy their software in multiple places and package them consistently.
Yeah. Also, the concept of machine actionability is relevant in that context. Huh? Yeah.
The other thing, so one of the things that we've come out of our efforts, and now also with the follow-on by COVID project, is what we call a tiered indexing engine. And so we've focused on data sets. A lot of that was about the F and the A in the FAIR, so find them and access them. And actually in the by COVID project, we've taken that to an indexing engine with different tiers. So some things can be deeply integrated. Molecular data can often be very deeply cross-linked. But if we then go to say, how do we cross-link genomic data with the social science data from the SSHOC, then the deep linkage isn't really possible. Yeah. But it's still meaningful to have cross-links. And in by COVID, we have sort of a tiered system where you can do that, and we've just integrated some of the social science catalogs. So you can, for instance, search for vaccine and get vaccine studies in all the domains of science. Yeah. But obviously, if you go down to molecular mechanisms, it won't be there.
Yeah, and this requires one of the things that's required for this kind of thing is a harmonization of vocabularies in the metadata structures. So yeah. But as said, it's very layered concept.
I just wanted to make a comment because I thought it's useful to notice, well, at least I saw in all your presentations and in ours as well, there's sort of the elephant in the room is what's called the EOSC MVE, or, the services that are being developed as pure EOSC and not by the clusters. Were not present in any of our presentations. We're not building on those yet. And so I'm keen to hear what Dale and Bob have to say in the next session. But I think, there is a kind of, it's difficult because they're happening in parallel. But I'm really, it'd be interesting to have a comment from the EOSC Association to know how we can converge, or if there will be convergence. Yeah.
Andy, if you allow me here to add on that what you just stated, I mean, concerning the services offered by EOSC, I mean, Niklas mentioned the Galaxy framework, which, for instance, will also be adopted by the ENVRI cluster for building on these Jupyter notebooks and workflows, etc. I mean, these kind of services they will be adopted, I think, by all the clusters on the long run. And as we mentioned at sessions also at the EOSC, the uptake of the of services offered by EOSC through the clusters will be driven by the usefulness to the scientific communities. As soon as we have services offered, for instance, by EUDAT or EGI or other e-infrastructures, they prove to be to serve a purpose. They will be used, and I mean that I think is the way we need to go to work along the needs of the scientific community, at least from the view of the science clusters, because then we are sure that the offered products are used afterwards.
Okay, well, thank you very much, all of you. Has been great to have you here, and we really appreciate the time that you take to go through the cluster projects and what has changed for all of you, this funding and this opportunity to build on the EOSC. So thank you very much.